F-22 Raptors. Easy-to-export stealth technology aircraft. The Lockheed Martin F-22 Raptor is an American single-seat, twin-engine, all-weather stealth tactical fighter aircraft developed for the United States Air Force, USAF. As the result of the USAF's Advanced Tactical Fighter (ATF) program, the aircraft was designed as an air superiority fighter, but also has ground attack, electronic warfare, and signals intelligence capabilities. The aircraft first flew in 1997 and was variously designated F-22 and F/A-22 before it formally entered service in December 2005 as the F-22A. Despite its protracted development and operational difficulties, USAF considers the F-22 a critical component of its tactical air power. The fighter's combination of stealth, aerodynamic performance, and mission systems enable unprecedented air combat capabilities. In 1981, the U.S. Air Force identified a requirement for an Advanced Tactical Fighter (ATF) to replace the F-15 Eagle and F-16 Fighting Falcon. Codenamed Senior Sky, this air superiority fighter program was influenced by emerging worldwide threats, including new developments in Soviet air defense systems and the proliferation of the Sukhoi Su-27 Flanker and Mikoyan MiG-29 Fulcrum class of fighter aircraft. Owing to the immense investments required to develop the technology needed to achieve performance goals, teaming between companies was encouraged. Of the 7 bidding companies, Lockheed and Northrop were selected on October 31, 1986. Lockheed then teamed with Boeing and General Dynamics, while Northrop teamed with McDonnell Douglas, and the two contractor teams undertook a 50-month dim/val phase, culminating in the flight test of 2 technology demonstrator prototypes, the YF-22 and the YF-23, respectively. Concurrently, Pratt & Whitney and General Electric were awarded contracts to develop the YF-119 and YF-120 engines respectively for the ATF engine competition. Contractors made extensive use of analytical and empirical methods, including computational fluid dynamics, wind tunnel testing, and radar cross-section (RCS) calculations and pole testing. The Lockheed team would conduct nearly 18,000 hours of wind tunnel testing. Avionics development was marked by extensive testing and prototyping and supported by ground and flying laboratories. As the program moved to full-scale development, or engineering and manufacturing development (EMD), the production version had notable differences from the YF-22, despite having a similar configuration. The wing's leading-edge sweep angle was decreased from 48 degrees to 42 degrees, while the vertical stabilizers were shifted rearward and decreased in area by 20%. To improve pilot visibility, the canopy was moved forward 7 inches, 18 centimeters, and the engine intakes moved rearward 14 inches, 36 centimeters. The shapes of the wing and stabilator trailing edges were refined to improve aerodynamics, strength, and stealth characteristics. The first F-22, an EMD aircraft with tail number 4001, was unveiled at Marietta, Georgia, on April 9, 1997 and first flew on September 7, 1997. Production, with the first lot awarded in September 2000, supported over 1,000 subcontractors and suppliers from 46 states and up to 95,000 jobs, and spanned 15 years at a peak rate of roughly 2 airplanes per month. The 1990 Major Aircraft Review led by Secretary of Defense Dick Cheney reduced this to 648 aircraft beginning in 1996. By 1997, funding instability had further cut the total to 339, which was again reduced to 277 by 2003. The F-22 cannot be exported under U.S. federal law to protect its stealth technology and classified features. Customers for U.S. fighters are acquiring earlier designs such as the F-15 Eagle and F-16 Fighting Falcon, or the newer F-35 Lightning II, which contains technology from the F-22 but was designed to be cheaper, more flexible, and available for export. The aircraft has an integrated avionics system where, through sensor fusion, data from all onboard sensor systems as well as off-board inputs are filtered and processed into a combined tactical picture, thus enhancing the pilot's situational awareness and reducing workload. Depending on the detected threat, the defensive systems can prompt the pilot to release countermeasures such as flares or chaff. The ALR-94 can be used as a passive detection system capable of searching targets and providing enough information for radar lock-on.